Yeah, good evening everyone. Shall we start the session within few minutes because of we are waiting for the some more participations. Hello. My voice is audible.
Suresh, is my voice audible, Suresh?
Audible, sir.
Yeah, Suresh, sorry for the delays. I was in a client meeting, so the client meeting extended for a few minutes. Sorry for the
Okay,
delay.
okay.
I will start the session in 2 minutes.
Okay, okay, sir.
Sorry for the delay. So there was a client meeting, so it was a little delay. So in the last class, is my voice audible?
Yeah, audible, sir.
Yeah, yeah, yeah. So in the last class, we have seen how to write a up counter. Okay, so how to write a up counter. So now let us see. So how to write a down counter using behavioral modeling in Verilog. So let us see how to write a down counter. So in the previous class, what we have seen, so we have designed a 3-bit counter, so whose initial stage is 000. So after that, for the next positive end of the clock, the counter is incremented by 1. So therefore, the next state of the counter is 001. So after that, so again the next state of the counter increases to 010. So later it goes to 011. So later 100. So like this. So once it reaches 111, so which is the final stage of a 3-bit counter. So again we are resetting it to 00. So this is the counter what we have designed in the previous class. Okay. So now let us design a down counter. So if you want to design a down counter, so first what you have to do, for example, I am designing a 3-bit down counter. So for example, I am designing a 3-bit down counter here. So 3-bit means, so let the initial stage of the counter is 111. So after that, what happens? The previous stage, the next stage will be 110. So after that, again the next stage will be 101. So after that it is 100. So like this. So once the count reaches 000, so again we have to reset the counter to 111. So that means first what we have to do. So first we have to initially make the counter to stage 111. So we have to initialize the counter to 111. So after that we have to decrement the count value by 1. So like this, once it reaches to 000, again we have to reset the counter to 111. Okay, so this is the operation we have to perform here. So for this, if you want to write the program here, so the first one is module down counter. So module down counter. So now let us take here. Okay, so what you can take here. So let the input be the A be the input. Okay, so clock, and Y be the output. Okay, so after that I initialize the inputs and outputs separately. So input clock. Okay, so later, so input the outputs and inputs. So initialize 3 bit means 2 down to 0A. So similarly output 2 down to 0Y. Okay, so when you are writing the program in the behavioral model, so what we have to make sure is that, so we have to make sure the output is declared in terms of the register. So register 2 down to 0. So this you have to make sure. So whenever you are writing the program in the behavioral model, that is by using the procedural assignment statements, the output should be declared in terms of register. Similarly, when you are writing the programming and the data flow model, so that means if you are using the continuous assignment statements, we have to declare it as the while. Okay, so now initially what we have to do first. So initially I have to assign. Okay, so what I have to do is, so I have to assign the output. So or else, so sometimes here if you want to use the sorry, assign the output to 111. So initially assign the output to 111 means initial y is equal to 3 dash b 0 0 0. Okay, so 3 dash b, sorry, it is the down counter. Sorry, so down counter means, so assign the initially the outputs to 111. So 3-bit counter, so that is 111. So after that, so I want the counter to be evaluated at the positive edge of the clock. So therefore always at the rate of pass edge. Okay, that is the positive edge of the clock. Pass edge of the clock. Okay, so where always at the rate of pass edge the clock. So that means for every positive edge of the clock here, what happens? So y is equal to, that is output y is equal to. So here since we have to use the if condition. Okay, so here we have not studied about the, so far we have not studied about the if else loop. So therefore what we can do is that we can go for the usage of conditional operator. Okay, so where y is equal to, so what is conditional operator? So first we have to write the condition. If the condition is true, so the true statement will be executed, otherwise false statement will be executed. So this is the operation here. So always at the end of the positive edge of the clock, so y is equal to, okay, so if y is condition, first we have to write what is the condition. If y is equal to 0 0 0, okay, if y is equal to 0 0 0, then what happens? So then what happens means, so we have to, okay, so the initial condition y is equal to 0 0 0. So what is the true condition here? The true condition will be the a value. So that is whatever may be the initial count, so whatever may be the a value you are taking here. Okay, so whatever may be the a value you are taking, we have to give it. So after that, then we have to take y minus 1. So that is the count value has to be y minus 1. That is y minus b dash 1 or y minus 1, anything is the same. So after that, end module. So this is the program how you write for a down counter. Or else, So here you can write the program simply by using no input also here. So here we can ignore the input value. So here we can ignore the input value also. So what you can directly is if y is equal to, if you ignore the input value here, okay, so if you ignore the input value here, so if y is equal to 0 0 0, so that means the decrement count is equal to 0 0 0. So again I have to take, after getting the counter value 0, so what I have to do is that again I have to initialize y is equal to 3b111, so or else y is equal, or else y minus 1, that is y minus 1 d1. So this is the program. So this is the program how you can write a counter program here. Okay, so this is how you can write the counter program. So so far we have seen the up counter as well as down counter using the behavioral model. So now let us see how you can write a program for a up down counter. So now let us see how you can write a program for the up down counter. Okay. So what is up down counter? Up down counter means, so we have a conditional input here. If the conditional input is equal to, if the conditional input is equal to, for example, so what happens? So you take a conditional input C here. Okay. If C is equal to 1, so you have to, the circuit should act as up counter. Okay. So that means the count should be incremented by 1. So if the C is equal to 0 means, so the circuit should be acting as the down counter. So that means the counter should be decremented by 1. So for this we have to write a program here. Okay, now let us see how you can write a up down counter here. So the first one is the same thing, module up down counter. So module up down counter. Okay, so after that, so initialize output y. Okay, so next clock. So now initialize input. So after that, so initialize here and input here. So let that input as a. So and initialize a conditional input. Let it be C. So now first what I am taking, I am taking a output of the counter y. So after that I am taking a clock. So after that I am taking the initial count, that is A. So after that I am taking the conditional input. So depending upon this conditional input, so we are able to perform the up counter or down counter. Okay. So now input. So input, so declare it. So input clock comma C. So why I have declared clock and C means, so these are the scalar vectors. So I have declared clock and C together. Okay. So next after that, input 3 down to 0 A. So declare a input, so whose value is 3 down to 0. So after that declare the output of the counter, so which is a 4-bit counter, that is 3 down to 0 y. So after declaring that, declaring the output, so since we are writing the program in the procedural model, so I have to declare the output in terms of register. So register 3 down to 0 y. Okay, so you have to remember that. So when you are writing the program in the behavioral model, so you have to make sure that you have described the output in terms of register. So after declaring the register, so first what I mean to do is that, so I have to initialize the counter value. Okay, so I have to initialize the count value. So now what I am doing is that, so initialize counter y is equal to 4-B00 0. Okay, so what I am doing is that initially I am taking the counter value as 0 0 0 0. Okay, so initially I have taken the counter value as 0. So now I have to make sure whether the counter should work with respect to the positive edge of the clock or negative edge of the clock. So now I want my counter to work with respect to the positive edge of the clock. So therefore always at the rate of passage clock, so at the rate of passage of the clock, Okay, so first what we have to see, so first we have to check whether the count is equal to, so that is whether the whether we have to do the condition, sorry, up counter or down counter. Okay, so in order to see whether we have to go for the up counter or down counter, means we have to go for the conditional operator. Okay, so a equal to C question mark, that means if C is equal to 1, okay, if C is equal to 1, then what we have to do is, so we have to uh, give the value of y is equal to A. So that means, so what I am doing here is, if conditional input is equal to 1, okay, so if conditional input is equal to 1 means, so first let us see here, if conditional input is equal to 1 means, so what I am doing, I am initializing the value of y is equal to A. So that means whatever the input value we are giving here, so whatever the input value we are giving, that input value I am assigning to the counter. So if the condition is false, okay, if the condition is false here, so that means if the condition is false, so next what you can do, so I have to increment the counter by 1, that is 1 dash b1. Okay, so that is 1 dash b1. Here I am going to see two types of conditions here, if y is equal to 1, and later, so y is equal to so what I got, so y plus 1 dash b1 else again, so in that else again I am going for the usage of one more condition here. So a is equal to 4 dash b000. So if the condition is equal to 4 dash b000, so if this condition is true here, so then what happens is that, so I have to execute A. So else y is equal to, else it is y minus 1 b dash. So it is end module. So it is the condition. First what I am doing, if C is equal to 1, if C is equal to 1 means this condition will be executed. So if C is equal to 1 means, then what happens, y is equal to A. So internally then counter will be implemented by 1. If it is not the case here, so so then what happens, y is equal to y, that is the output is equal to, sorry, output is y here. So y is equal to y minus b will be executed. So here I am using the loop. So or else simply what you can write the program is in the sense, see what you can write is, so y is equal to, what is conditional input, C. So if y is equal to C, okay, so if the condition is true here, so in the true condition what you should write is that, so we have to do the addition operation. So initially what I am taking, y is equal to 1, so that is y plus 1 dash b1. Okay, so y is equal to 1 dash b1. Okay, so in that here, so again internally I have to use one more condition here. Okay, so what is the else condition here? So C is equal to 1 means I have to increment it by. So internally again what I have to use the condition. The condition is that y is equal to, okay, so or else C is y is question mark, so or else if y is equal to 4 dash b000, okay, so y is equal to 4 dash b00, so that means if y is equal to 000, or else if it is up counter means y is equal to 1111, so then what happens, the counter has to be decremented. Okay, so or else again it has to be resetted. So if it is the true condition here, so what you should write is that, so y is equal to 4 dash b000, else, so what you have to write is that the counter has to be decremented. So this is one more condition. So what you can write for the up down counter. So like this you can write the program in the behavioral model. So whenever if you want to write the program in case of the data flow, or in case of your data flow or gate level modeling. So it takes more amount of space, as well as so it takes more amount of more gates in order to write the program. So that is the problem by with the gate level, or else if you are going for the data flow also, the complexity of the programming is very difficult. So therefore, it is very difficult to write the behavior of the program by using the data flow as well as the gate level. So in order to make the programming very simple, so we have to go for the behavioral model. So once you know the behavioral model, so it is very difficult for us. Okay, so very easy for us to write the programming in the behavioral model. So now let us see the few constraints. Okay, so few constraints in terms of the behavioral modeling. Okay, so first see as the constraints regarding the blocking and non-blocking assignments. So blocking and non-blocking assignments. Blocking and non-blocking assignments. So a group of non-blocking assignments. So these are called the group of non-blocking assignments, and these are the group of blocking assignments. So less than or equal to is the non-blocking assignment, and equal to is the non-blocking assignment, and equal to is the blocking assignment. Okay. So all the assignment within the initial or always block considered so far. So we have considered so far by using the equality operator. So this equality operator is the blocking assignment here. So when you are using the blocking assignments, so the statements will be executed sequentially. That is, so after the execution of the first statement, the next statement will be executed. So like this, so one by one, the statements execution will be done. Okay. So such assignment blocks with the execution, so these are called as blocking assignments. So further, when a blocking assignment has time delays associated with it, the delay is applicable to the following assignment or delay also. Okay. So when you are using the less than or equal to symbol, okay. So when you are using the less than or equal to symbol, so it is the non-blocking assignment. Okay. So the here the main characteristics of this non-blocking assignment is that the execution will be done concurrently. So the execution will be done concurrently. So let us see a small example here. So how you can describe. For example, A is equal to 3-B000. So after that, B is equal to 3-B001. And after that, C is equal to 3-B011. So this is the group of values. So now, if you see here, what happens is that, so here all the three assignments are executed concurrently here. That is A, B, C. So all these three assignments are executed concurrently, and they are assigned to the value of 0, 1, and so there are three here. So they are assigned to the value of 0, 1, and 3 concurrently and not sequentially. Okay. So now when the program is when we run the program here, what happens is that so all these values are assigned to the variables concurrently. So now when you are using this, for example here, let us see one more example here. So if A is equal to 3-B000 and B is equal to 3-B001, and A implies B and B implies A. Similarly, A is equal to 3-B000. So B is equal to 3-B001. A is equal to B and B is equal to A. Okay. So if you see here, what happens is that from this two things here, so what you can assume is that, so initially I have assigned the value of A to 0 and the value of B to 1. Okay. So when you execute this, execute this, what happens is that, so the non-blocking assignments, so in the first thing here, so the non-blocking assignments here are essentially two-step affairs. Okay, so for all the non-blocking assignments in a block, the right-hand sides are evaluated first. Subsequently specified, the assignments are scheduled. So, if you consider this, so for the first A is assigned to a value of, so the first A is assigned to the value of 0, 0, 0 here. So A is assigned to the value of 0, 0. So then B is assigned to a value of 0, 0, 1. So these two things, then the two assignments are sequential here. First, what happens? The value of B is the value, the A implies B. So it means that the value of B stores separately, then it is assigned to A. Okay. So the value of B is stored and it is assigned to A. So 1 minute.
Sir, also please mute yourself, sir. Your voice is not audible.
So here what happens is that, so when A implies B means the value of B here, so it stores, first it will be as read here. What is the value of B here? The value of B is 0, 0, 1. So then the value of B is assigned to A here. Okay. So therefore the new value of A is 0, 0, 1. Similarly, when it takes the value of the next step here, what happens is that the value of the value of A is 0, 0, 0, and this value of A is assigned to B. So I think now the value of A becomes 0, 0, 1, and the value of B becomes 0, 0, 0. Okay. But what it happens is that, so when you execute this program, first the right hand will be executed. Okay. So what is the value of B here? The B is 0, 0, 1. So at a time the value of B is assigned to A. Similarly, the value of A is 0, 0, 0, and this will be assigned to B. So therefore, the value of A becomes 0, 0, 1. The value of B becomes 0, 0. Why? Because the programming is executed concurrently here by using the non-blocking assignments. So when you are coming for the blocking assignments here, so first what happens? A is equal to B. So what is the value of B here? So the value of B is 0, 0, 1. So therefore, what is the value of A becomes? The value of A becomes 0, 0, 1. That is 3BT. Similarly, we are using the non-blocking assignments here. First, this statement will be executed. So after this statement will be executed. Now the value of A becomes 0, 0, 1. So now B is assigned to A. So therefore, again the value of B becomes 3-B 0, 0, 1. So now here the both the values of A and B becomes 3-B 0, 0, 1. So this is the difference how you can execute the values of A and B, okay, by using the blocking and non-blocking assignments. So in a short, what you can say is that, so if we are using the blocking assignments means, so the statements will be executed sequentially, that is one by one. If we are using the non-blocking assignments means the statements will be executed concurrently here. So the thing that we have to keep in mind. So this is the example. The first example here is, so I have taken the value of A is equal to 3-B 0, 0, 0. The value of B is equal to 3-B 0, 0, 1. So when you execute this program here, what happens here? A implies B. So what is the value of B here? The value of B is 0, 0, 1. So therefore, the value of A is taken as 0, 0, 1. So simultaneously, the B value is assigned to A. So now what is the value of A here? 0, 0, 0. So that is, this value will be assigned to B. So therefore, the value of A and B will be 0, 0, 1 and 0, 0, 0 respectively. Now, when you come from the blocking assignments here, what happens? Initially, I have taken the value of A is equal to 3 dash B 0, 0, 0, and the value of B is equal to 3 dash B 0, 0, 1 here. So since I am using the blocking assignments here, what happens is that, so first the statement A will be A equal to will be executed. Okay, so A equal to B here. Okay, what is the value of B? B value is 0, 0, 1. So therefore A becomes 0, 0, 1. So when the next statement executed, the value of A is already assigned as 0, 0, 1. So therefore the value of A, that is that the current value of A 0, 0, 1 will be assigned to B. So therefore the value of B remains as 3 dash B 0, 0, 1. So it is the difference between the blocking and non-blocking assignment. So like this we can able to see the difference between the blocking and non-blocking assignments. So now after that, let us see a case statement. So now let us see the case statements and if statements. So how we can write the programs by using the case statements and if statements here. Okay. So the case statement is a very elegant and simple construct. So that is used for the multiple branching in a module. So well, there are some multiple branches in a module. So we are going to use the case statement here. Okay. So the when you are using the case statement, the important keywords are case, end case, and default. So these are the important keywords. So when you are using the case statement here, so case statement, that means so when you are getting the output by using the multiple conditions, okay, then we are going to use that. So now let us see a syntax of this case statement. So first case expression. So here the expression is nothing but the condition. Okay, so expression reference 1 statement 1. So when the condition is with respect to the reference 1, the corresponding statement, and when the condition is with respect, expression is with respect to the reference to the corresponding statement. So like this we have to write. So for the last statement we have to go for default. Okay, so default statement end case. So it is the thing here we can write the program. So the first whenever you are executing this, first the expression is evaluated. Here the expression is nothing but the condition. So if the condition or the expression will be matching reference, means the statement will be executed and the simulator will exit the case statement. For example, if the reference to is matched, means the statement which is with respect to the reference to will be executed and it will exit the case statement. So like this, depending upon the expression here, the corresponding references will be executed. So whatever the references we have given here, so all these references are not satisfying the expression, means then the default statement will be executed. Okay, so when we are going for the case statement, so what we have to make sure is that, so suppose here we can use the default statement or you may not use the default statement depending upon your programming skills. So now let us see a small example here. So I want to design a 2x4 decoder. Okay, so I want to design a 2x4 decoder. So what is 2x4 decoder? So here I am not taking any enable input here. Okay, so for example, in a decoder, if the two inputs are I0 and I1 and the outputs are what I can take, so it is Y0, Y1, Y2 and Y3. So if the inputs are 0, 0 means then the decoder output line Y0 will be activated, so on the remaining will be 0. So if condition is 0, 1 means, so then Y1 will be activated, other things will be 0. So if it is the inputs are 1 0 means, so then y2 will be activated and the remaining will be 0. If the inputs are 1 1 means, then y3 will be activated. Okay. So this is how you can write the decoder truth table. So now based on this truth table, by using the case statement, you can write the functionality of your decoder. Okay. So module, what is the module name here? So decoder 2 by 4. So what is the output here? Y is the output and the input is I here. So now specify the inputs and outputs separately. So output, so 3 down to 0, Y, and the input is 1 down to 0. So 2 input. So we have to make sure that we have to declare the output in terms of register. So register 3 down to 0 Y here. So after that, next what you have to do, so when you are writing a program in the behavioral, we have to use the always statement. So if you want to use the always statement here, so always at the rate. So with respect to which of the input the output will change here, there is only one input. So whenever the input changes, so the following statements of the behavioral model should be executed. So that means whenever the input changes, the output also change. So therefore, always at the rate of I here. So begin the always statement. Now come to the syntax of case. Okay. So what is the syntax first? Case expression. So case expression means, so here what is the condition here? The input is the condition. So depending upon the input, your output values will be changed. Case I. So what is the first condition? If, that is case I. If I is equal to 0 0. So if I is equal to 0 0, so the what should be the output here? The output should be 4 dash. So coming from y3, so that is 0 0 0 1. So that is, it is y3, y2, y1, y0. If the input condition is 0 0 0, y0 will be activated. So that's the same thing I have written. Similarly, if 2 dash b 0 1, so it is means, so 4 dash b 0 0 1 0. So if the input condition is 1 0 means, so the output will be 0 1 0 0 0. Okay. So now, so if it is 2 dash b 1 1 means it is 4 dash b 1 1 1 1. So here I am not going to use any default statement here. So if you want to in case of the last statement, if you want to use the default means, so instead of writing the last statement here, so directly what you can use that, so default. So apart from these three conditions, for giving any other condition means, so this particular statement will be executed. Okay. So if the input is not 0 0 or 0 1 or 1 0, so automatically, so y is equal to 4b dash 1 1 1 will be executed. Otherwise, so with respect to the reference what you have given, the corresponding output will be executed. So otherwise, what you can do is the sense. So if you want to use the default, if it does not want to use the default means here, so you can create it as 2 dash b 1 1. So after giving all the possible input conditions, next one will be the end case. So after the end case, next what you can do is that, so you have to close the always block. So therefore we have begin the always block, next to close the always block. So therefore end. So next end module. So this is how you can write the program for a decoder. Similarly, let us see. So in the previous class, what we have done, so we have written the ALU program. Okay. So in the ALU program, what we have written. So this is the ALU program. So this ALU has two inputs, A 3 down to 0 and B 3 down to 0. These are the two inputs, and it also one more input which is known as the CN. Okay, that is the input carry. So it is also having one more input, that is F, which is the conditional input. So based on this condition, the ALU will do the sum of the operations. That is, if F is equal to 0 0 means, so addition operation will be carried out. If S is equal to 0, 1 means subtraction operation will be carried out. So if F is equal to 1, 0 means I am going to do the XOR operation. If F is equal to 1, 1 means I am going to do the bitwise AND operation. So these are the things we have seen in the last program. So how an ALU works. So now let us see here. Similarly, we have an output here. So let this output as C naught here. So sorry, or else let the output as sum here. So let the output as sum. So there is C out, and also the sum is 3 down to 0, and C naught is the output carry when you are doing the addition. So now let us see how you can write the program using the sum. So using the case statement means module. First case statement. So don't use case. Case is the keyword. So I am using case st, that is case statement. So case statement ALU you can write. Okay. So what is the output here? Sum comma C naught. So next write the inputs A comma B comma C in comma F. So after specifying the outputs and inputs, so now next in detail specify the outputs. So output 3 down to 0, yes. So it is the sum. Similarly, output C naught. So after that again specify input 3 down to 0, A comma B. So here A and B are the two inputs. So whose length is 3 down to 0. So after that input C in here, and also there is a conditional input here. So which is nothing but F here. So the size of F is 2 bit, that is 1 down to 0 F. So next we have to, when you are writing the program in the behavioral model, so you have to write the program in the register model. So in the, that is in the register. So 3 down to 0 S and also register C naught. So register C naught is the output here. So register C naught is the output. So next after that, so what here we have to do is that, so first use the always block here. So always block. So when you get the change in the output, when the input A or input B or the conditional input F changes, there will be change in the output. So therefore always. So when A or B or F, so when there is change in the input A or input B or input F, so we can able to see the output. So now begin here. So begin. So first we have to use the case statement. Okay. So what is the case statement here? So the condition is F. So based on the input condition, the output changes. So based on the condition F, that is case F. Okay. If the F is 0, 0, we have to perform the addition. So therefore the output S becomes, or else addition means, so you get it as C naught comma S. So C naught comma S is equal to A plus B plus C in. So that is input A plus input B plus C in. So if the condition is 0, 1 here, what happens? Sum is equal to A minus B will be done. That is the A minus B will be assigned to sum. So if the F is equal to 1, 0, what happens? We have to do the XOR operation. Therefore, output S is equal to A XOR B. So similarly, if it is 1, 1 here, the input is 1, 1, we have to do the bitwise AND, that is A and B. So after this, I have given all the input cases for the case statement. So after this end case here, so after doing the termination of the case statement, next we have to do the termination of always here. So therefore, end the always block. So after that, end the module. So this is the main programming, how you can write for a case statement here. So this is how you can write the case statement here. Okay. So now, if you want to write the test bench for this program, so for example, I want to write the test bench for this program here. So what I can do is that module test bench. So what are the inputs here? So the inputs should be declared as registers. So therefore the inputs are A comma B. Okay. So register C in. Okay. Register 1 down to 0 F. So whatever the inputs are in there in our main module, that should be declared as the register. Similarly, after that we have to declare the outputs as whites. Y that is 3 down to 0 S, and also white C naught. So next we have to instantiate the top level module. So what is the top level module I have taken here? Case statement ALU. So next I have to copy the same primitives, that is S comma C naught comma A comma B comma C in comma F. Okay. So this is I have instantiated my top level module. So that means, so the program with this module name will be instantiated. So now after that initial begin, so we have to give the input values. So now there are different input values, so you can assign the input values. For example, initially at 0 time units, I want A should be 4 dash B 0011 and B is equal to 4 dash B 1100. So at the time I want addition, therefore F is equal to 2 dash B 00. Similarly, after 2 units of time, so I want the input values of A and B as 111 and 0011. So assign them. So at the same time, I want subtraction, therefore it is 01. Similarly, after 2 units of time, so I need the input values A and B, and also I can give the value of C in here. Okay, so 1 dash B0, C in is equal to 1 dash B1. Okay, so B is equal to 1110, and I want to do the XOR operation of this. Okay, so therefore the XOR operation what it becomes is that uh, uh, B dash 10. So similarly, so assign after 2 units of time A is equal to, and you take F is equal to 2 dash B11. So after assigning all these values, so next what you can do, you can end these assignments. Then if you want to view the output, means you can go for the dollar monitor. So dollar time. Okay, so A is equal to percentile B. Why? Because we are assigned in the binary. Similarly, B is equal to percentile B. Similarly, F is equal to percentile B. C in is equal to percentile B. And sum is equal to percentile B. C naught is equal to percentile B. So A comma B comma F comma C in comma S comma B. So after that, so after 10 units of time, we have to stop your simulation. So initial as can stop. So next end module. So this is the thing how you can write your test bench when you are going to use your test bench for the given EIAU. So this is the case how you can write the test bench. So if you are writing the test bench in any model, so the test bench will not change. The programming pattern of the test bench will not change. Only the logic of your main module will be changing when you are changing the modelings. Okay. So that's all for today. In the tomorrow class, so we will see about the if statements. Okay, if statements, as well as we will see about the for loop and while loop in the tomorrow class, and we will see more examples. Okay, so that's all for today. So I will hand over the session to Suresh. So if you have any doubts, means you can ask me.
I have to suggestion any software. Is that possible, sir?
Hello? No, Suresh. No, Suresh, your voice is not audible properly.
Okay, I will do normal talk.
Okay.
If you have any, please ask to resource person or bonus. If you have any notes, yeah, thank you, sir. Yeah, no, this session. Yeah,